Sorry, I got the Zoom voice distracted me. Yeah, dynamic input. So there's input that changes. The way you can think about it is if you have a program that accepts a list of strings, what happens when the list changes? If you have to recompute from beginning again, then that program is something that we call an offline program, because it will have to recompute everything again from the beginning. To illustrate this further, we're going to take a look at an example. So we'll take a look at everyone's favorite, sorting algorithms. Just curious if anyone knows of an example of an offline or online sorting algorithm. I guess the Slido is like Q&A, but you guys can also use it to answer questions. Or maybe not. Oh, I see merge sort. Is merge sort online or offline though? Yes, so merge sort is offline. Thanks for the support, people. I don't know your name since you show up as anonymous here, but I really appreciate it. Yeah, so merge sort and quicksort are both offline algorithms. For today's examples, I've picked a more simpler one, I guess much more inefficient one as well. So I have selection sort here as an offline algorithm. As a recap of how selection sort works, first it's going to iterate through the entire unsorted list, pick the smallest value, and bring it to a sorted list. So for our example here, say 63917, my first iteration, I'm going to get 1, bring it forward, repeat the same step, get the smallest value 3, repeat the same step, and get 6. And this is where we're at in terms of sorting. I'm gonna then inject our dynamic input, so we get a new value to sort in our list, 2. On our next iteration of selection sort, it's gonna go through 972. It's gonna get, it's gonna see 2 as the smallest value, and then it's gonna bring it forward, resulting in this. So you see how selection sort doesn't do well with this new data, and hence like why it's offline. Is insertion sort offline? So sorry, I got distracted as well by the Slido questions. And my iPad just dropped. Let me put it here. So actually, our next example to counter selection sort is insertion sort. Insertion sort is online because we'll go through the exact same cases for selection sort, but we'll get a different result. So here for selection sort, we have 6319117 again. A recap for insertion sort. What it's going to do is start from the first value, insert to the new list. So like 6 will be, we'll start with 6. 6 is the sorted value. Then we go to the next value 3. We'll insert it into the right position. So we'll go right before 6 and we'll get 3, 6. We'll go to 9 and then insert again in the same right position and we'll get 3, 6, 9. And then we'll add a new element again, 2. But on the next iteration, what insertion sort will do is look at 1, try and insert 1 in the right position. And so instead of where selection sort has failed, insertion sort here successfully continues running on and returning a sorted list at the end. I hope at this point everyone has a good understanding now of online algorithms and what the differences are. I hope that when you guys go back to your algos 101, you guys will think about this online and offline property and like see which ones are online and offline. Cool. So we've covered what online algorithms are. Let's take a look at real life applications. Do you guys have know of like a real life application of online algorithms besides, of course, like Jane Street for trading? Exams. Why would you use? I guess you're right. I guess you would need to know online algorithms for your exams. So for the real life application, you can imagine online algorithms in different contexts. You can use them in, say, self-driving cars. The program that runs the car has to be able to handle like new and like dynamic information from the environment, right? If there's a red stoplight, then your program has to suddenly stop and like react to it very quickly. For today, my example will be how we use this at Jane Street. So at Jane Street, we're a trading firm. We have a lot of models that try and calculate the real value of a given stock. And this is actually really hard to do for many reasons. But in the context of online algorithms, our models have hundreds, thousands, millions of like parameters. And a lot of those parameters might even be partial. Like we might not even have that information at the beginning of when we started like our model computations. A lot of the information we do have is also very dynamic in the sense that, well, you see Bloomberg, you see like every second, like the ticker changes. And so that's like something our programs have to like constantly be able to take into account and reflect. So this is just like a simplified diagram. Here at the center of it all, we have Jane Street as a company, and our output is the price of a given stock. So as an example, our model might take into account some financial information. It can also take in like news, financial data. And also the actual value of the underlying stock might also be impacted by other relevant stocks. So stocks in the same industry or in competing industries. You can think of it as if Tesla produced a new phone, this would probably mean that there's more competition for Apple, and there's probably some form of mathematical relationship between those two. Yeah, so you can imagine a system that runs this, that takes this into account and like manages to calculate and model the price of the stock. But as I mentioned earlier, we might have tons and tons of all this information. And so having an online system that can react to all this quickly and not have us to recompute everything again, every single second something changes, is very important to our success as a trading firm. All right. So at this point, you guys know what online algorithms are. You know, like ways in why they're like useful, ways in how they can be used. Our next topic is called self-adjusting computations. Self-adjusting computations are a subset of all the online algorithms out there. As the name suggests, it refers to computations that can effectively figure out the minimum amount of recomputation needed when some small input changes. In particular, the reason why we're exploring this is because, like I said earlier, if we have good understanding of self-adjusting computations, we can use some of the theory behind it into making our systems online. So let's take a look into that. When talking about self-adjusting computations, we think of them best as like a computational graph. So you can think of it as a dependency graph. So here I have, say, int z equals x plus y. I have a graph here that kind of expresses the relationship between the variables. So we have the green nodes like x, y, and z. They x and y are, have arrows pointing towards the plus. So that's just expressing how x and y's are like input going through this plus. So it's like a computation node. We apply the arithmetic addition function to x and y to produce a new variable output z. Notice here that the graph is directed the graph is directed so that it shows data flow, and it also has to be acyclic. Does anyone know why these computational graphs have to be acyclic? Also, thank you for all the questions about Jane Street and other bits. I will go through them at the end. Yes. Thanks for the last anonymous. Yes. So our computational graph represents how the flow of the program. And so if there is a cycle in the graph, it means that the program will not end. It's going to recurse endlessly into it's an infinite loop. Cool. It seems like you guys have a good understanding of computational graphs. So let's take a look at some examples of some problems and how we can view them from the perspective of using a computational graph. Right. So x plus y is easy. Anyone can do 3 plus 5. Let's try and solve a more complicated example, which is calculating matrix dot product. Here I just have a copy from Wikipedia. The formula, I think it's not really, you don't really have I hope you guys are all familiar with this from linear algebra. To calculate the dot product, you just calculate AI, BI, and sum them all up. So here's what the computational graph will look like. I'll give you guys some time to look at it. I wish I had time to manually add animations that they appear one by one, but that's a bit too much. So here we have it. So we start with 0. We add the sum of, say, A0 and B0. They're variables referencing to the actual values of the matrix. And then we add them up again with A1, B1, and so on and so forth. Now, if someone asks me to implement this, I'm gonna implement the offline solution in the sense that if A0 or B0 change, I'm just going to let my code recall the function that I've written. Right. So that means that whenever a variable changes, my code will likely have to recompute the whole thing. So that's the offline version. If it's not hard to imagine as well that if one of the traders asked me to, I could also spend some effort and think about making this online by making checks to see caching the previous values of each position in a matrix and figuring out what to recompute. And so there exists a program that you can write such that when B1 changes, you just recompute the nodes in red instead of the whole thing. So the reason I create this, I distinguish these two is because Well, it's possible to make a lot of programs self-adjust. It just means that you have to spend some effort thinking and trying and make it work. It adds some complexity to your code. Imagine as well that if you have tons of tools and systems, it's quite a lot of work to ask every single author or like maintainer of each system to think about like how they can self-adjust their programs. Like you can think of it like, oh, like say if you can self-adjust in program A and you want to self-adjust program B, there's also like, there's duplicate work in thinking about it. There might be some duplicate code, like making sure it works for A and B. And so that's pretty expensive. And this is where the incremental library comes in. And this is also where the title of this talk comes in. The reason this talk is called Online Algorithms Made Easy is because we came up with Incremental as a library that can make all your programs self-adjust. So Incremental allows you to, Incremental makes it easy for you to make your, to write programs that self-adjust. And effectively, that means that you can write online algorithms very easily. Like all the programs that use Incremental are online. And so for today's, over the next few slides, I won't have the chance to explain how Incremental works in like the underlying implementation of Incremental. But what I'm going to do is show you its like interface, and from that signature, hopefully you have a sense of how the library can be used and how you can think about your code and make them self-adjust. At this point, I'm just going to review some questions before we move on. Someone asked if Incremental is a Jane Street's private library. Incremental is a library written by some folks in New York. It's based on the research of, I don't remember if it's Caltech. His name is Umut Akar. If you look up self-adjusting computations, there's like some papers on that. So that's what Incremental is based off. It is open source now. So if you go to Jane Street's GitHub, you can see Incremental library and its implementation. And it is all written in Ocaml, so it might be tough for you to like properly read and understand bits and pieces. So I would actually recommend a YouTube video that we posted perhaps a few years ago. So if you look at like, if you search up like Jane Street Incremental on YouTube, there's some videos that like go through in depth on how it all works underneath. Cool. As to commutative operations, you'll see in a bit more. I think I'll leave that question after we go through Incremental. All right.
Hi, Stephanie. Sorry to interrupt, but
yes.
If you scroll all the way up the Slido, there are more questions there as well.
Oh, do you know how they're sorted?
Oh, yeah. So like if someone likes a question, then it moves to the top of the list.
Oh, sorry. Yeah, I did not see the votes. If you self-adjust, then won't it require a lot of caching and storage of data? The answer is yes. So I will, there's like, somewhere in my slides later, I will talk about the caveats of using Incremental, which is exactly this. Using Incremental does mean that there is some overhead in caching, storing, figuring out which nodes to recompute and such. And so it is true that Incremental should not be like used for all use cases. If your program is cheap enough that that recompute is cheaper than using Incremental, then you should just run the recomputation. It is like not like you have to give some trade-off at some point. It's not, there's no free lunch. Can an operation node only have 2 inputs? The answer is no, you can have as many inputs as you want. You can think of the computational nodes as functions that accept like n number of arguments. So that, hope that answers it. I've just made it, I've only have like examples with 2 nodes currently, just because I want simple examples that like fit into the slides. But yes, you can have n number of inputs. Okay. Well, unfortunately, I'm probably gonna spend a long time if I have to like, figure out how to sort this Slido link. So I will hope that just stop me if, or upvote your friends' questions so that they come up. Cool. Oh, sorry. Did someone unmute and want to ask a question? That's also a fine choice. Okay. I'm going to continue for now. And like I said, there'll be lots of time after for questions. So I will go through all of them later in the end. And we can always go back to the slides. Right. So where was I earlier? I was talking about incremental and the goals of writing incremental. We wanted to make it easy for developers to write software as graphs. I particularly am like a visual person, so I really like seeing the dependency graph and how they work. Incremental is also used to make, like I said earlier, make programs self-adjust. So it can efficiently recompute. It helps you efficiently recompute the graphs based on the nodes that you've declared. The last bit is it allows a centralization point for all the self-adjusting algorithms. And this is important because it means that you're not duplicating the work between each system that you make self-adjust. So you can think of it as like, if, yeah, this means like less duplicate code. It means it saves a lot of people's time. It also means that one team can specialize on incremental and focus on thinking on optimizations and improvements that would immediately like bring any benefits, share all the benefits to all the systems that use incremental. And so it is a really powerful library, and it's something that's really helpful for us. Okay, so like I said earlier, I will not go through with the actual implementations, but I think seeing the, we'll just go through the interface, but even that I think is, well, it will give you enough of like understanding of how the spirit of the library, the spirit of the library. It's, since the library is written in Ocaml, the next few slides has some Ocaml code. I have simplified it, and so I think, and I've also tested this on some of my friends who are not devs. And so I hope that if you guys want me to slow down, please do so. Say something, but otherwise, I do think it's a very interesting language. And by giving this short introduction to or this introduction by Ocaml, it gives you a better chance of actually understanding the library if you do choose to read it on GitHub. Okay, so back to where we were before. This is just a recap of our diagram, our legend. I have a simplified example here that we're going to go through step by step and see how we can make the nodes in code form. So it's almost the same as earlier, like x plus y equals z, except I added an intermediate like operation in which we take the absolute value of x. So let's take a look at I'll show the incremental interface, the node, and the actual code that I would have to write if I wanted to use it in my programs. Okay. Sorry. All right. Cool. So for starters, we really just want to be able to declare the incremental variable. We just really want to say here, I just want to create x. On the left is our simplified version of the incremental library. So incr is just short for incremental. That's just the name. You can think of module as like a Java class. So and sig is just saying that this is the signature. So all I'm saying is that there is an incr namespace, and inside incr, there is a type node, and the type node, well, represents the nodes that we want in our graphs. So what can we do with the type node? With the current interface, we can't actually do anything. All we know is that you can type, the node type exists, but you can't create it right now. You just can't do anything with it. And so since we want to create our nodes, I also expose different functions of the interface. And so, yeah, okay. So our first function is called create. Val is just declaring that there's a value. You can ignore small bits of the syntax, but we have a function here, create. It's going to take in an integer, and it's going to return a node. And so if I want to use it, I can just say let x be an incr at x be a node. Oh, okay. This doesn't sound right. Sorry. I will say x is equal to incr.create3. So what I've done here is incr create3 creates a node with the underlying value equivalent to 3. And I'm saying that x is this node. Ocaml is smart in the sense that it does, it figures out the type for you. So you don't have to keep on declaring in the same way as C or Java, oh, this is int x, and so on and so forth. All right, so at this point, we've actually created a node x equals 3. I hope that's not too bad. We can also do the same for y. So I want to create another node y. I also this time I want to give it the value 7. I just call incr create 7, and that returns me a node y. And we want arrows, right? Our graph is nothing with just nodes. We need the arrows to show the relationship between these nodes. So that is done by a new function, apply. Apply takes in a node and a function f and returns a node. The function f is declared to be a function that takes in one argument, an integer, and returns another integer. F colon here is just saying that this argument has a name. And so when we pass it, we need to give it a name as well. And so the arrows in our graphs are kind of representing the application of a function, right? It's saying that do something to an input to create a new computation node. And that is what apply does. Apply will take in your node, your input node, and the function f. It will run f on the values in the input node and return you a new node so that you can chain it along to the rest of your computational graph. All right, so let's use apply. I'll name the node abs_x to say that this is the node after we apply the absolute value on the input node x that we have earlier in our example. So I just call incr.apply on the node x and apply the function here f int.abs. Int.abs is just saying, oh, get the absolute value of the integer. And we have our first arrow. I hope this is not too bad. All right, so then we have one arrow, but that's really not enough, unfortunately. We want to be able to see how we can say, get two inputs and combine them together, right? Otherwise, our graph is going to just be like one straight line forever. So new function comes into play. The incremental library also has the function called combine, which, as I've just described earlier, it will take in two nodes and a function f and returns a new node. So combine will take two nodes, use the function f that takes in like two integer arguments and returns a new integer. We name this, like, we just pass, like, you know, so f is just saying that the argument of the function is labeled. It doesn't mean much if, like, just because apply and combine both take in like a function f, they don't actually mean that apply and combine have to be like the f have to be similar, like same in any way. In fact, the f here is actually different. The f in combine takes in two arguments, like two integers int, and returns a new integer instead of just one. Okay, so we can finally get our z by calling incr.combine on the two nodes abs_x and y and applying arithmetic addition. Oh. But the interface also, the incremental interface also has the function called recompute. As you might guess, recompute also recompute will recompute like all the values underneath. Oh, wait, sorry. Does anyone know why we need to call it recompute and why we choose to like not just have recompute run automatically in the background? Yep. So we did this for efficiency. As we mentioned earlier, using incremental is already like, there is already overhead in like tracking everything. So we want to try and reduce and minimize the cost of using incremental as much as possible. And so we call recompute as lazy. With lazy, what we mean is we want to do as little work as possible. We will only recompute the nodes that need to be recomputed, and we only recompute each node at most once. How I think about it is, if, say, I guess a good example is if you have your system that calculates, say, the price of X, and all the inputs to that determine the price of X might change every second. But if you only want to actually trade X, say, at the end of the day, you can just call recompute right at the end of the day before you actually use the value, so that you don't have to like waste the computation, like waste CPU and memory computing the changes throughout the entire day. All right, so back to our code earlier. Before we use z in like any sort of meaningful use case, we should call recompute first. Yeah, also I did not mention like recompute signature, but it's just, it takes in a unit and returns a unit. Unit is just like void in Java or C. So it just takes in like kind of like a way of expressing nothing. Oh, that's right. Cool. Yeah, so we've seen how, going back a bit, we've seen how we've actually made this little graph in our code. And I'm not gonna go through the getters, but the interface also has like some functions to get the values. So there's a function called value that takes in a node and returns like the int type under the int value underneath. You can also like change the values of the variables that we created. So we can call like set to change the node, like it takes in a node, takes in an integer and returns a unit, or like it's a void function. There's a function on update that takes in a node and a function that takes in an integer and returns unit. So on update allows you to kind of register a callback on a node. For example, and like whenever it changes, the function f will be called on the value underneath. So you can imagine this being super useful for debugging. When we're trying to say, figure out why computation is not working, you can attach like a function that just prints the value every time it updates. And you might notice at this point that so far the values of our graphs are just integers, but the actual library allows for generic types. That means it allows for strings, other types that you can declare in Ocaml. And I figured that simplifying it to just an int makes it easier and quicker to understand. Cool. So with that, we've managed to put this entire graph and encode it in our code with the help of incremental. You can also bring things to scale. So this is like, you can imagine each computational node being some very expensive function to recompute. So going back to our example earlier of like pricing a stock, say or pricing an ETF, say like S&P 500, say the price of S&P 500 in our terms is the sum of Apple and like some Google stock. We might apply like fancy functions that like say we can scale the value on how much the price depending on like the ratio of like the component of the stock in the ETFs. You can also imagine like expensive functions that calculate the risk of holding an ETF for longer periods of time. And so even though all we've seen is like simple examples with ints, it's not hard to imagine how like bringing them all up to like scale. Yeah. So I mentioned this earlier when someone asked about it. There are caveats to using incremental. There's overhead in tracking all those elements, changes, and dependencies. And so it is true that it cannot be used everywhere. We have to make sure, like there is a trade-off that the developers of the system have to decide on whether it's worthwhile using incremental or not. Now, here's something interesting. What if we don't know the inputs that are needed in the first place? Like, oh, so since I spoiled it, I should just continue on. It's possible that we don't know what our graph will look like. The market might have sudden changes, or there might be new stock, new flows that we want to trade. And sometimes we want our systems to like be able to handle all this dynamic information as best as possible. And so this is where static and dynamic graphs comes in. What do I mean by static? So far, what we've seen earlier with our example, it's just been a static graph in the sense that you have code that declares the dependency, like the computational graph and like how it looks like. And throughout the runtime of the system, it's never going to change. And so a dynamic graph is one that can change during the lifetime of the system. So as the system runs, it might choose different dependencies and like construct a new graph entirely. So again, let's look through it with an example. The good one is like an if, for example. So suppose here I want to declare this dependency graph. I have this computational node like an if function. So like the if will check if it's like a positive number based on the condition input. So if the condition node is positive, then it'll return, then like use 5, otherwise use 100. So let's take a look at how we're going to express this in what we already know so far. So let's declare this as if it's a static graph. Yep, so there's 3 arrows, but we can actually still express this with what we have earlier. And the way we do that is by modifying the graph a bit so that it looks like this. So notice like if the condition, so we have a condition, we can combine the condition and the true logic into an if true node, and then we can combine it again with another input node, like the else node, and to generate the final value. And this will effectively be the same, but this only works because we need to be able to express whether it's like true or false when we pass it to the if true node. So I'm just going to show it to you with what the incremental interface that we've seen before. So to declare the if true node, I can call this incremental combine. I'll call incremental.combine again on the original condition and the then node. And so then we'll pass in a function, f, and the f takes in 2 arguments, I, the value of the condition at the time, and then underscore val. Then underscore val is the value of the then node at that given time. And so if I is greater than 0, then I will say sum then val, otherwise none. What is sum and none? These are called optionals. And so it's just a way of expressing like you might have a value or you might have nothing. And so in Java, you might like how you might do this is by saying, oh, else return null, sorry. But null is a bit bad because, well, you have to like handle null exceptions potentially coming everywhere. So in Ocaml, we have an optional. It's like, so you can either have a sum value or a none. All right, so we have the if true node. We can then have, to get x, we call again incr.combine on the if true node and the else node. And we pass in another function f. Now this function f takes in 2 arguments, cur val and else val. Again, cur val is based on the if true node and else val is based on the else node. And so what we do now is check if cur val is sum. So we check if it's none or not, right? If it had sum, then well, the condition must have been true initially and must have returned like a cur val. Otherwise, we just return the else val. And so with that, with our example here, we now can express our what if graph statically. But ideally, what we want is this. We want it such that there is like no arrow between else and if, because then otherwise underneath incremental has to do like some amount of work whenever else changes, like some amount of tracking. We also, or yeah, here's also like, yeah, so if the condition is false, we also want only the else arrow to be connected. So this is what I mean by dynamic graph. We want it to like change on the go in a way. And of course, if we're talking about dynamic graphs, what if the nodes can also create more nodes? And this is all actually possible with incremental by having this new function called bind. And so I've copied like the interface of incremental that we've seen earlier, just so that we can do a comparison here. But let's focus on bind. Bind is a function that takes in 2 arguments. It takes in 1 node, and it takes in a function that takes in an int and returns a new node. So contrast this with like apply and combine, where the functions f in those only return like ints. And so with bind allows you to return new nodes depending on the value of the input node in the first place. So like using bind on like our value earlier, we can call like incrbind on the condition and a function f. The function f takes in a single argument. And if the argument is positive, then we can return the then node or return the else node, and that will generate what we have here. And so this is not possible if without bind. It's kind of magical. It is pretty magical. All right, so that is all I have today for in terms of the incremental library. If you guys are curious and want to check it out, you can check like the link on GitHub. Like I mentioned earlier, the library has generics, not just integers. I've also renamed renamed the functions. So what we see today is apply is actually called map, combine is actually map2, recompute is stabilize. All right, so just a recap with what we talked about today. We learned what online algorithms are. We've learned how and why they're useful. We've learned also what self-adjusting computations are, how we can think about self-adjusting computations as graphs. And we've also seen the incremental library, which allows you to, which is the general solution to a bunch of programs so that they can all become self-adjusting computations. With that, I'd like to thank everyone for listening up to this point and open up for questions. Actually, before I go through all the questions, there is an upcoming event. So Janetree is going to have this virtual electronic trading challenge on October 23rd. What you do is you sign up as with your friends to form a team, and you're gonna trade in this mock exchange that we run. And so you're not gonna be trading with us. You're gonna be trading with some bots as well as other teams' bots. So it's a pretty fun event. If you guys are interested, do sign up. And there's our Facebook. I think our recruiting team regularly posts different events there. So if you guys are interested in any of them, you can subscribe and follow. And that the email careers@janetree.com is there if there's any questions that I failed to answer today. So you can just forward them to the recruiting team and they'll get back to you. Of course, again, thanks everyone. I hope you guys all learned something. You guys are also welcome to unmute and talk with me if you prefer that over Slido. Otherwise, I will go through our Slido. Cool. So I will start from top to bottom. What are some qualities that stand out to you or make for an ideal candidate? I think really after, there's like a bunch of qualities. I think for me in particular, what I've noticed is like, I'm gonna like, a lot of people in Jane Street are smart, but they're also like really great people to work with, in the sense like, um, I've I've asked a lot of questions and no one has ever made me feel as if I'm like dumb for asking those questions. And so I think the ideal candidate is someone who's like curious about the world, willing to learn, but it's also like um nice person to work with. And that means like different things for different people. For me, someone nice to work with is like someone who's like willing to collaborate, like I don't know, someone who's willing to listen. It's like, yeah, you have to be technically strong, but you also have to be, in the end, like a nice human being. So I hope that clarifies it. Um, yeah, be a nice person, even to your interviewers, whether it's to Jane Street or to like any other company. And I think it actually goes a long way. What motivated you to join Jane Street or the trading sector? So um, curiously, I actually nearly did not apply to Jane Street. Back in like uni, I just like spammed my resume everywhere. And like, I was fortunate enough that I sent my resume on the last day that the Jane Street applications closed. And so um, I went through their interview process. I think the reason I joined Jane Street is because I really liked the interview questions. Um, the interview questions to me were like very interesting. Um, they're like kind of designy, but like generic, kind of like more generic problem solving than just the regular of like lead code, memorize your algorithms and like make it work. And so I went through the whole process. I was very happy with like my interviewers, like the people I met and like the people I've talked to. And I decided that Hong Kong was a very interesting place, coming from Sydney. So I decided to make the trip. And I'm very happy so far. Yeah. I would say that day to day, my job is less trading related. And so like in Jane Street, we have like various teams. It's kind of crazy how many like the breadth and like the scope of things we do for such a small company. Like Hong Kong only has like 200 people all in all, like traders, software devs, and all that. And yeah, there's like, even as a software engineer, there's various roles. So like for me, I work more on like the core services that like other devs use. There's teams that work with market data where they have to like be performant. There's also teams that work on like the trading desks that like, and so they help the traders implement all the strategies. And we also have our own like in-house tools and compilers team, just because, well, we're like the biggest industrial user of Ocaml. It does kind of mean that sometimes we have to like invent the wheel ourselves. But I guess that's what makes it very interesting as like a software engineer. You can choose the kind of projects and problems you're interested in, and there's like always kind of something for you to do. So yeah. Does any stock trading in Jane Street happen manually? Yes, there is still like manual stock trading happening in Jane Street. I think it varies a lot desk to desk. So I think more traditional, what do you call it, instruments like bonds, stock trading is much more manual in the sense that sometimes it might even be through like a phone call. So it varies a lot on the instrument that's being traded. Can an operation node only have 2 inputs? Okay, so we've covered that. What is the frequency of the computation? Like how often do you recompute? I assume, so this question came up at around the time when the recompute interface was showed up. It's up to you. It depends on how often you want to use the computation. So the benefit of allowing the client to choose when to recompute is that you can have it whenever you want it. And like incremental is smart. If you call like recompute twice, but then there's nothing extra to recompute, it's not gonna recompute. Am I correct to understand that only commutative operations can be included in this graph? So I guess, I don't know if this question still applies. I think like the graph is like an abstraction of different computations, but you can imagine like connecting the graph in different ways and like it having more complicated computations in each node. Where can we use incremental outside Jane Street? I think I'm not actually sure if other languages have a similar library like incremental that can do self-adjusting computations. I wouldn't be surprised if there were, because their research is like public. I think your usage of incremental is kind of limited with usage of Ocaml, but I think it's not crazy for you to imagine if any of you decide to pursue a career in academia, if you guys are working in the functional programming space and decide to use Ocaml as a language, you could imagine using incremental for some, say, AI or machine learning work. Additionally, I think even though it's, say, not accessible, it's not crazy for you guys any one of you to like implement incremental for a different language and share it with like the rest of the community. I think the reason I like this talk is because incremental is kind of like an idea. Now that you have this idea, it's up to like the possibilities are kind of endless there. It's up to your creative imagination. Why does Ocaml look so different from regular programming languages? I think if you have seen Haskell before, perhaps maybe it's like less surprise. I think the functional nature of Ocaml makes it look a bit more different. So I can it is, I understand that it is pretty different. Did take more than usual time for you to get used to its syntax? Yeah, so we don't require any of our applicants to know Ocaml beforehand. I did not know Ocaml before joining Jane Street. What happens is like on your first week, you just spend a week doing boot camp and learning the language. I figured like, I think Ocaml to me is like very mathematical. It kind of reminds me of like algebra and like the kind of declarations and stuff. Yeah, we do. I can go into like a whole tangent on describing like why I like Ocaml and like language features that make it nice. But I'm sorry that like I think if I had more time preparing for this talk, I would have like changed the interface to like a different language to make it easier for you guys to understand. So I might consider doing that next time. Yeah. How long is the Jane Street interview process? It depends if you're going for an internship or straight to full-time role. But I guess for both, normally there's resume screening, and then you get invited to a phone interview. So that will be just, I guess like a phone interview where you like share like a coder pad session between the interviewer and you. And after that phone interview, you get to go on site. So before we would fly our candidates to Hong Kong, but because it's so difficult, we currently have what we call non-sites. where you have a row of interviews back to back for like around like I think a day or half a day. And after that, that's that. So it's one way it's like shorter than other companies or quite similar, I guess. I think my Google internship interviews were like also off that range. Yeah. Cool. I think that's all that I have not answered. Yeah, with what if the operation is not associative, how can they accept multiple inputs? If you think of each node as like a function that can accept any number of inputs, that's what the graph nodes are representing. So it's entirely possible that you can have like as many number of arrows as you like. Is there only one CoderPad interview before the onsite for internships? Yeah, there's only one CoderPad interview before onsite for internships or for straight to full-time role. So what is the onsite like for software engineering internships? So it's a lot similar to the phone interview in the sense that it's like around a 40-minute question. The difference is just that, well, we do 2 interviewers for per interview, so that I think that way we get like a fairer read. And the kinds of questions kind of change a bit in the sense like there's technical ones, but there's also like designy ones. But I would say that how I would prepare for them would be the same. And I guess the onsite is also more tiring because it is like multiple interviews in a row. I think by the end of my onsites, I was pretty tired. All right. I'll give it a moment. Okay. By designy, do you mean system design kind of questions, and how many interviews might there be for the onsite? So I actually am not sure. I guess like a system design question, I'm scared of like, I'm not sure what you mean by system design kind of questions. I think that system design kind of questions mean differently for different like people. And so I'm like careful about answering that. I think the best way to prepare for system design questions in general is by trying to build like a system yourself. Say, like the difference between, I guess with school projects, or at least my uni school projects, a lot of them were like, kind of, here's an assignment, do it, and your code lives relatively short term. But if you were to build a system and try and like keep it running for like longer periods of time, you practice, like you start to gain some like understanding about different parts of your system design that are more beneficial and like more maintainable in the long run. Yeah. And how many interviews might there be for the onsite? I think it depends, but I think you can expect like 2 to 4. How would you prepare for Google Jane Street coding interviews? You mentioned LeetCode previously. How would you recommend any additional resources? There is a blog post in, like, I think there's a Jane Street blog post about how we do interviews. if you guys haven't seen it before, I would recommend taking a read. It's like a pretty short blog post, but I think it kind of like describes the spirit of how we think of interviews, which I think is really useful because a lot of the times when I was a student and I was the interviewee, I got really stressed and I got very nervous at interviews. I think it really helps a lot if you make the realization that your interviewers are actually on your side and they really want you to actually pass the interview, right? Like we want to hire people. And so that helped me overcome a bit of my nervousness. And that was something I kind of got from reading the blog post. That's why I recommended it. I think different people also learn differently. So what I'm going to suggest is like what I did as a student when I was preparing for Jane Street interviews. Different people might do different stuff. I did quite a bit of lead code. I read the Cracking the Coding interview book, just so that you have like an understanding of like problems that were commonly asked and you have like a general sense. I also did a lot of mock interviews. So I think that is probably very important and probably the missing piece for a lot of people. It's easy to like do lots of lead code and feel confident, but it's kind of a whole different challenge writing up code and also like talking and explaining it to someone. And so practicing like mock interviews goes a long way, especially if you tell your friends to like be strict with you and like give like an angry face kind of, I don't know, like these are kind of the things that I think like the emotional aspect of like the person to person aspect of interviews are, I think, hard. Where do you practice mock interviews? So in university, I had my computer science society ran mock interviews where like some of the older students would like practice mock interviews to like the juniors. So I'm not sure if NTU has that or WIT does that. I think that's like something I found useful. You can do it with your friends. Like you guys can like practice, like pick a question from lead code and like practice running it with each other. And that goes quite a long way. Is there anything you don't like or someone here potentially may not like about working in Jane Street? Let's, this is like a question that I've not properly thought of. I think, okay, I think something that people might not potentially like in Jane Street is perhaps because we're such a small company, I feel like I have my hands quite full in the sense like I have quite a lot of systems and stuff to take care of. And so like that can be stressful and for some people. Additionally, kind of knowing like, you know, if like your system breaks down, what it means for like the company and all that, like it's fairly critical. And that adds like a weight of responsibility on your shoulders. And that is like sometimes it is scary. And it took me quite a while to get used to like that fear of like, you know, if you cause like a big bug, like you might halt trading and stuff like that. So that is something that might seem scary. I also think like if I don't know if people, I personally like smaller companies. So I guess this is like what I just described earlier was like a property of small companies, but I can imagine people not liking that. Like there are some like, I don't know, like with a big company, you have like, yes, a different kind of community. Like with Google, you guys they have their own like systems to do A, B, C, and so maybe like it's a personal preference, I think. Additionally, we also have like a flat structure. So I don't know, like if in the sense that sometimes I don't know who the people around me are. Like the person sitting beside me might be someone who's been here for like 10, 15 years, and I wouldn't have a clue. So yeah, I don't know, like sometimes I can envision some people wanting to know who like a hierarchy of like people in the company. Okay. What is one main challenge you face in your work at Jane Street? I think, yeah, like what I mentioned earlier, like being able to maintain a lot of systems. There's a lot of context switching. So I can be writing code and then because I guess like other big other big tech firms, their clients are like the general public. So like Facebook, they're all like the millions of Facebook users out there. But for us, our clients are like traders or other dev teams. So a benefit of this is like, oh, we can go next door and like talk to your clients and ask what they want. But the converse is also true. Your clients can come knock on your door and like request A, B, C, D, E. And so being able to balance like client requests, having the time to work on them, having time to like make bug fixes, and like yeah, I guess, and like when there's like an incident or like things on fire, being able to react to them like under stress. I think those were like my main challenges working at Jane Street. Are these coding interview questions relevant to what you are doing for your job? I think some of our coding interview questions are actually inspired from actual problems that some of our systems have solved. I think the more interestingly, I think, is having this like in a coding interview, you're working with your interviewer to kind of come up with a solution to a particular problem. And so that's like something that I do day to day. Like whenever there's an issue, um, it's not one person's like, it's not that my manager decides or like what fix to write and how we're gonna do it. It's always like a team effort of us discussing and agreeing on a solution that we like. And so I think the coding interviews kind of like have that spirit of collaboration. And I think being successful at that in your coding interview, like being able to work with your interviewers, I think is very similar to like working day to day. Okay, I don't really have a background in sweet trading, but I'm keen to start. What are some tips you have for people who are interested in breaking into this field? So I'm not sure what you mean by sweet trading. If you can post if there's like something in mind that you were trying to refer to. I'm not sure if you mean like as a general software engineer or as a trader or like a mix of both. I guess for me, I came as just a full software engineer. I have like very little background in trading. We do have like traders or like software engineers. Oh, I see. For us in Jane Street, I think we value a lot the ability to learn. So like for our internships in particular, an important part of our evaluation is like being able to gauge how like someone's potential in like learning. Like if you're a fast learner, that is like something that we value quite a bit. And so I think like to become a software engineer at Jane Street, I don't think you have to do anything particular in like as in like learn anything like trading terminology or anything in like special. I think like if we are happy to hire you as a software engineer, like any like I feel like I'm sorry, I'm doing a terrible job of speaking. My words are failing me. I think if you do a normal software engineering degree, you are you should be well equipped to become a software engineer at Jane Street. We have traders who are like in the middle in the sense that they do some trading, but they also write up code tools and strategies. And so that's a bit more tricky. Usually people who become those like in-betweens are either traders who have shown a talent for coding, or for devs who like people who've done a dev internship and like decided that they're interested in trading, do a trading internship, and then end up with a mix of both. But where like, I guess the line is kind of like flexible, and that is something that gets discussed after like we've seen like people's like your strengths and weaknesses.
Hi, Stephanie. Sorry to interrupt. Could we wrap up the session right now?
Sure. I think there's only one last question. Would you like me to answer the last question?
Or we can take one more question.
Okay, maybe for trading for someone who may not be able to get into Jane Street, are there any particular experiences or knowledge that you could improve yourself with? I'm actually not sure what this question means. Do you want to like come on Zoom and elaborate? I'm not sure if this question is like how to become a better trader. But I think trading is like very different from software engineering. I feel ill-equipped to answer this question. So thanks a lot, everyone. Oh. I'm not as in a trading internship or a software engineering internship. So I guess the question is, if you're not, if you can't get a software engineering internship at Jane Street, are there any particular experiences or knowledge that you could improve yourself with? I would recommend, I'm not sure if this question is like a reflective one, or if like, I think if you're not applying because you don't believe that you can get into Jane Street, I would strongly recommend to just still apply anyway, because I think the interview experience gives you good practice for like other upcoming interviews. And I don't know, they're just really interesting problem solving. You get a chance to like work with like an experienced person and work on a problem. Yeah.
Okay, thanks for the questions, everyone. I think we'll be stopping the Q&A here since we are really running out of time. So
Sorry
if
about
you
that.
don't, no, it's fine, it's fine. Thank you for being super participative and like really making this session interactive and informative. And if you don't mind right now, we'd like to take a screenshot of everyone here. So please do turn on your cameras. All right, just gonna wait like a few more moments.
I feel like I should have changed my background here.
It's all
You
right.
guys have all such nice backgrounds.
Okay, last 10 seconds for anyone who wants to switch on their cameras, then I'm gonna take the picture. Okay, everybody, smile, please. 1, 2, 3. 1, 2, 3. Okay, thank you so much. Now just give us a few more moments and then we will go very soon. Okay, so I think we can all agree that this was an incredibly informative and insightful glimpse into the world of online algorithms. And thank you so much, Stephanie, for taking the time to speak with us today. We really appreciate it. And welcome to the WIT family. It's nice to have you with us. And to all of you, you've been super participative today, and we really appreciate the effort you went to stay behind after lessons and just like listen to us and take the time to participate. So hope you all have learned something and gained something from today's talk. And do follow us on any of our social media platforms if you would like to keep up to date with our future initiatives. And if you are sharing your experience today on any platforms, do not forget to tag us at Women in Tech in NTU. A quick shout out to the WIT team behind today's session. Srishti, Claire, Vedika, Akshachi, Shane, Noor, and Nisha for putting together the session and for doing all the media and publicity collaterals. To the rest of you, good night and good luck for the rest of the semester. We'll see you very soon.
Thank you.
Thanks, Stephanie.